So here is a typical question that leads into what we're doing today. And you have to be able to solve stuff like this. If you can factor it, you should, is a great way to like start. And then if you can clear fractions, that's another good option. But rewriting was the key to this one. And if you said log base e of 5 equals x, you were right on. Raise your hand if you had that one right. Awesome. I'm curious if anybody did it this way. Log base e, and they put a log in on both sides. And then you should know that this can go down to the front, and therefore it just turns into x. And you get the same thing, but your x is on the left this way, which is kind of nice. I don't know, did anybody do it that way? One person. All right. So that's an option. You can just put in a log base, whatever base you want, in this case log base e, on both sides. This turns into 1 with the x in front of it, so it's just x equals log base e of 5. Same answer. All right. I'm going to give you one more like that. E to the, let's make it 2e to the 4x is equal to 8. Everybody solve that one. I'll pause for a second. You try that. What do you think of that? Okay. Now what? Go ahead. Okay. Now it's rewrite time. L, what'd you get next?
I got log base e to 4 equals 4x.
Of 4 equals 4x. Good. And now how do you get that 4 off of there?
I just divided by 4.
Okay. I am curious, when you divided by 4, did you divide the whole left side by 4, or did you put a 1/4 in front of it? No judging, just asking.
I just divided.
All right. Dividing by 4 like this is okay. Did anybody instead put a 1/4 in front? Okay, nobody even, oh, one person. All right, that's good thinking, because that actually works better often. All right. Do you get how times it by 1/4 is the same as dividing by 4, right? Okay, so it's just nice, because then you could, if you wanted to, you could pop it up on the exponent if you wanted to. See what I mean? Whereas if it's underneath, you couldn't do that, so. All right, cool. Solved for x, we're done. And I know this is kind of complicated looking, but do you get, it's just something you could put in a calculator, it's just a decimal. Okay. On the test, you won't have calculators, so you'll be able to leave them like that. All right. Now, let's do a little bit of review. This is just referencing how you often have like multiple strategies. You could call an electrician, you could call a plumber. On logs problems, there's a lot of ways to do it. I showed you that on the first problem. We are not doing this lab, yay. Instead, let's talk about this type of question. This one's a little too rough. It's supposed to be a use substitution, but it gets really complicated and took a lot of our time last hour, so I don't think it's worth it. Instead, we're going to go right to problem 2. And on this one, I have one more rule to add to my little list of tips for you. You know, if you can factor it, you should. What else is on that list? If you can factor it, you should. What else should you look for? Rewriting, clear fractions, good. There's one more thing. If you can condense it, you should. That can condense. But something has to happen first before I compact it back down. You have to do things in order. So the first thing that has to move is that 2. This 2 right here. You can't condense that into one log unless you get that 2 out of there. So where does it go? And will you be careful with that? All right, everybody give that one a shot. I'm going to pause for a second while you solve number 2. All right, how many of you caught that when this 2 has to move up, it has to square both of them? How many of you caught that? Or should you just randomly pick the x? Like, that is a 2x. Why would you just square one of the two things? Just because it's a variable? No, you're going to square the whole argument, all right? So it should have been squared like that. Then, if you can condense it, you should. And so this is a log, and I've suggested always that you use the base in there, because even though it doesn't have a base, we know the base is 10. And if I put it together, 2 squared is 4. X squared over 4. Why did I divide? Because there was a minus here, and you gotta know those rules. And that equals log base 10 of 2x minus 1. A lot of little things to know. Then, did you know? I don't know what just happened there. Hold on just a second here. Okay. There. Did you know that these two will cancel? Raise your hand if you got the logs out of there. You didn't know that? Okay. Well, how about you take it from here then and see if you can solve it once those logs are gone. Because if they're the same log base, that's why we condense it on the left side, so we only have one log on each side so that the logs can disappear. Technically what's happening is that this is just equal to this. Well, that 4 cancels, and you're just left with x squared is equal to 2x minus 1. The reason pre-calc is so hard is that you have to remember all of algebra. And one of the things from algebra was that you should be able to solve a quadratic like this. You should know that you can set it equal to 0 first.
Shouldn't it be 2x squared?
Nope, because this 2 got squared into a 4. And then the 4's cancel each other right here. The reason it got squared is I bet you just put the squared on just the x, and you should have actually squared the 2 and the x. So the 2 squared becomes 4. 4 disappears when it cancels the other 4. Okay, now we're down to this, and now one of my rules comes in. Which one? If you can factor it, you should. X equals 1. And last hour I double checked it. I'll just save us the time. 1 worked. Yay. And the reason I check it is because sometimes they don't. Sometimes you go through all that work and it didn't actually work. All right. I know you guys aren't awesome at this yet, but keep in mind the test isn't until Friday, so we've got time to fix this. Tomorrow's another new day. Review of today plus some more new. Then on Wednesday, and then on Thursday's a review, and then Friday's the test. Okay. I think these 3 questions are nice and clean and simple and very important for you to know how to do. Okay, so everybody just solve these. They shouldn't be super hard. Don't think like it was too easy. No, they're supposed to be pretty easy for you by now. Do them in order, please, because I'm going to ask you in a minute to like compare with the kid next to you, and if you started with number 3, they won't match up real nice. So get the first one done, then get the second one done. All right, I'll pause while you work on that. Okay, let's do a partway through check. Compare with the kid next to you, see if you got number 1 the same as them at least, maybe number 2. If you're stuck, ask for help at this point. Okay, time to answer these. I'll see if I can do them efficiently for you. Same log on each side now. Since there's only one log, didn't even have to condense. It's just x equals 3x minus 2. Subtracting x from both sides, 0 equals 2x minus 2. If you can factor it, you should. I'm noticing it factors. 2 comes out, x minus 1. Yay, since it's set equal to 0, x equals 1. Maybe you didn't do it that way, but I factored it. And if I'm thinking I'm right, then I'll go back and check it quick and see if I'm right. You know how to do that, right? I just stick the 1 in. And is this really true? Log base 7 of 1. Oh, I know that one. It's 0. Won the argument. You get 0. 0 equals, I put in a 1 here. It'd be 3 minus 2, which is 1. And log base 7 of 1 is 0 again. 0 equals 0. 1 worked. Did anybody find a different answer for it? Did anybody else notice that you could factor it? All right, one person did it that way. The rest of you just didn't notice the factoring again, which is okay, but there's another way to do it, I know. Just trying to show you, factoring comes up everywhere. Okay, this one, if I was gonna do it, I'd do a rewrite. I can't factor it, right? So I'd probably go to rewrite. And so this is log base e of 2 equals 2x minus 1. You get what happened there? Is x alone yet? Then I got to subtract 1 from both sides. Now this is a really important, sorry, add 1 to both sides. This is a really important moment. Do you get a large number of people would think this is log base e of 3 now? But it's not. It's log base e of 2 plus 1. That's different? Yes, it is. Do you get log base e of 2 was a complete little package, and then I wanted to add 1 to it. It's still a complete package here, and then I want to add 1 to it. All right, now I have equals 2x. Now I'm going to have to get the 2 off of there. I'm going to divide everything by 2 or multiply by 1/2. As I do that though, remember if I multiply by 1/2, I got to multiply this whole thing by 1/2. Or I got to divide this whole thing by 2. So I'm going to choose the whole thing divided by 2. Log base e of 2 plus 1 all over 2. That would be a good way to answer that question. Could I have multiplied both of them by 1/2? Sure. If you really like that better, I'll put a 1/2 here instead of dividing by 2. And I'd have to multiply this by 1/2 also, and 1 times 1/2 is 1/2. That would work. Okay. Any questions about that one? I know a lot of people's head just exploded when I added 1 and I didn't add it to the 2. But I hope you get that this log base e of 2 is a number that I want to add 1 to. Just increasing this one by 1, making this 2 into a 3, that doesn't increase that left side by 1. All right, so be careful with that. All right, and these problems are all here for a reason. This problem's are here because we're reminding you that you can drop the logs on both sides. That's the main thing there, okay? And a little bit of watch for factoring. And this one's here because of that. Most people know it's a rewrite, but then they screw up that little algebra part where you add 1. So why is this one here? What do you think is the common mistake in doing this problem? Well, how about this? What should you do? I change it to log, and this is here to remind you if you can condense it, you should. Log, and it has no base. Oh, that's important. I'm going to put a base 10. And then I'm going to combine this and this with a minus means divide. So I'm going to have x over 2x plus 1. And that gets so messy, I'm putting a parenthesis around it to show that's what the argument is. Equals 1. And then, easy place to get stuck. Can factor it, you should. No, it's not that. Clear the fractions. No, not when it's in the middle of a log like this. So this is a rewrite. 10 to the 1 is, of course, just 10 equals that. And why is this problem here? Because you got to know how to clear the fractions. You won't be able to solve this thing unless you clear the fractions at this point. So you times both sides by 2x plus 1. And that disappears. And now I have multiplying that out. 10 times the 2x makes 20x plus 10 equals x. Subtracting x from both sides, 19x plus 10 equals 0. Can't factor that one, so I'm going to go 19x equals negative 10. X equals negative 10 19ths. Raise your hand if you had that one, same as me. Awesome. Now, did any of you take the time to go back and check it? Anyone? That should be on your list of like ways to not screw up on this test. Look for factoring, look for clearing fractions, see if it actually works. Oh crap. All of that work, and now when I put the x right there and I make it negative, you can't do that? You can't have a log of a negative number. Okay. Any questions about how I did that? Do you think I made a mistake? Do you think you have an answer that works? Because, hey, if you have an answer that works, you're better than me. Like, if you got an answer and you actually stuck it in and it worked, please tell me now. You'll save me a lot of pain having to remake this video. Anybody think they had an answer that worked? Okay. All right. How many of you thought the answer was negative 10/19? Be honest. All right. 3, 4, 5 of you. All right. And it's easy to forget to check it, isn't it? All right. Now, that's things you're supposed to know about solving. And I've spent a lot more time than other people. I found out one of my colleagues didn't do any review of solving equations like this. They just figured that the kids had it down from over break. I'm feeling like I'm glad I practiced with you because even this wasn't super easy for you. How many of you got 2 out of 3 of these problems right without me? Okay, good. That's a good sign. All right. So now we need to really get to the new stuff. And what is the new stuff? The new stuff is about making exponentials out of real world problems. So let me go back to what you're supposed to know about exponentials. Y equals 2 times 3 to the x. That is a typical simple little exponential. Why is it an exponential? Because it has the x and the exponent. And this was the starting amount. And can you tell, is this thing going to double or triple or cut in half over time? It's one of those 3 things. Is this going to double, triple, or cut in half over time? It's going to triple. Okay. And then this is where the time goes. And this is how much you have at the end. Okay, process that for a minute. We have a starting amount. We start with like 2 turtles, and we're breeding turtles. And the turtles are going to triple over time because we're breeding these turtles, and we're not going to like let them get exposed to predators that are going to eat them. And so the number of turtles will grow dramatically. Does that mean every day? No. The amount of time could be like 5 years, but the number of turtles will triple over some amount of time. And at the end, we'll have some number of turtles. Now, you with me so far that that's the basics of exponentials, is you have an x and the exponent. Okay, you're supposed to already know that, but that's why I reviewed it, because maybe you didn't. All right, so here is the new equation for today. This is a big one. Now, it's already written down. I know it's tough to make you say, here, you better write that down, but do you get that if you don't actually write it down, you're less likely to remember it? So let's write it down in the context of using it. So let's go off to the side and say n of t equals n sub 0. That's the number at time 0. So this is the start amount again. Ooh, this is the end amount again. Ooh, it's like setting up like a normal exponential. Except wait, all of a sudden there's an e, because this is involved in the real world. It's about uninhibited growth. Most things are actually inhibited in the real world. But if you had uninhibited growth, this is the equation you'd use for like how many bunnies there are or whatever. This is if there was no predators. Okay, and then you put it to the power of k times t. K is tough to describe. It's the only one that's tough to describe. All these are easy. This is how many you have at the start. This is how many you'll have at the end. Remember, n of t is just like f of x. It's like a variable. It's just a variable. And then this is time. The only one that's hard to describe is k. K is, well, it's the only thing that kind of depends on how fast this thing grows. We know how much we start with. We know how much we end with in this kind of problem. And k is the factor that will determine whether it's growing by a lot or shrinking by a lot, but k is a constant. So we just say, I'm going to do something to help you remember it's a constant. I'm going to spell constant with a k. K is for constant. All right, now, imagine you look out your window, or you've been watching a movie, and then you look out in the street, and there's a giant bunny standing there looking at your house. Would that be illegal for somebody in a bunny costume to be on the street looking at your house? No, but would it be extremely creepy? Most of you would probably not sleep well at night. So, anyway, it would be much more comical if there was lots of bunnies. It would still be very bizarre, but it would be just more like, oh, a bunch of people, not like a crazy person. All right, so we start with 14 mega bunnies in year 0. That means when we start the experiment, there's already 14 of these really big bunnies. It'd be really nice if we'd just, after year 1 you get this, after year 2 you get that, but it's not. It's year 3, we now have 44 bunnies, and apparently they're growing uninhibited. Nothing would eat these, they're too huge, and so the mega bunnies are growing. Okay, so how do I do this? That equation I had you write down, now let's stick the numbers in it. What was the start number? Because whatever that is, I'm going to put right here. What was the start number? Say it. Come on, participate. What was the start number? 14. There was 14 mega bunnies at the start. We put a 14 here. Okay, what was the end number? Not the very, very end, but after this period of time, what was the end number? 44, and it goes there. Okay, and now, what's E? Well, it's E. E is always E. It's like saying, what's pi? Well, pi is 3.14. E is, it's about 2.718. It's this number that's always the same. And then there's K. I don't know K. And then there's T. Do I know the T for this little part of the experiment right here? Do I know the T? Say the T if you know it. 3. See this 3 right here? So then there's a 3 for the time right here. Guess why I had you practice solving things like that earlier this hour? So you'd be able to solve it now. Everybody solve that. You might be like, solve it for what? There's an E and a K. That's a dumb question. Wait, Mr. Server, that's not supposed to be dumb questions. You can't solve for E. E is a number, 2.718. You can solve for K, though. So everybody solve for K. I'll pause for a second. In a moment, I'll have you compare what your answer is with the kid next to you. Don't go use a calculator. Your answer is going to be like 1/2 ln of 17. You know, it'll be weird like that. It'll have a log in it. It'll have fractions in it. I'll pause for a second and give this a try. Okay. Compare with the kid next to you. It'll be weird looking. Okay, and I know there's some people who did it different ways and you're not sure who's right. And the people who divided by 14 first, you're right. Raise your hand if you divided by 14 first. Okay, good. And then, I know there's another thing that you could have messed up. First of all, do you have to simplify that? Yes, you should simplify as much as you can, and they're both obviously even numbers. Okay, so you really should be able to say that's 22/7 pretty quickly. Equals e to the k times 3. And then you should know enough to say, if it can factor it, you should. Clear fractions. Oh, if you clear the fraction right now, though, you won't be able to rewrite it anymore. So clear the fraction's a good thing in general, but if I times by 7, I won't be able to rewrite. You can only rewrite when this base here is alone. There's nothing in front of it like this. So this is a good time to rewrite. Log base e of 22/7 is equal to 3k. I switched the 3 and the k around. Hope that's okay. And then I'm going to multiply both sides by 1/3. And the 1/3 cancels off the 3. Now, if you just wrote that all divided by 3, do you get that's the same as a 1/3 in front? Raise your hand if you had that one right. Awesome. Now, here's the tricky part. We now have what k is, but we don't have the final answer. Is the final answer k? No, the final answer is how many mega bunnies there would be in year 8. So now we have to go back and do the problem again, except we know what k is. So what do you start with? The formula. So n of t, everybody write the formula down. I'm telling you, if you don't have the formula like written down and then stick the things in it, you're going to screw this up. N of 0, e to the kt. Now I put in what I know. I know, now this experiment I'm doing is to say the 14 is the start and the ending is year 8, and I don't know how many there are in year 8. That's why it's more tricky. So now I go back and I put in my 14 to start with. That goes here. The ending number, I don't know. So I put n of t. I got to leave that as a variable because I don't know what it ends with. The number of bunnies is unknown. E to the k t. Let's leave k out for just a second. Do you know that we know t? It's right here. It's the 8. Year 8. So this is an 8 times whatever k is. How am I supposed to know what k is? Because you just solved for it. It's right there. And I write that right here. 1/3 log base e, would you agree that's ln of 22/7. There's my answer. That's an answer? Yep. This all right here is a power on this e. Could that be simplified even more? Yes. But we wouldn't make you simplify it further. It's good enough. It's solved. How do I know it's solved? Because there's only one variable. And it's that variable equals the other stuff. All right, let's see if you really got that. I'm going to give you as simple a problem as is humanly possible. Would you agree that if you started in year 0 with 2 cats, and it was a male and a female cat, it's possible that 4 years later, you might have 8 cats? You think that's... In fact, you're probably going to have a lot more than that, but do you get how that's a realistic, simple scenario? Okay. Then, let's say 1 more year later, wouldn't it be likely you'd have even more cats if you're allowing them to breed? So this is the year, this is the cats. In year 5, how many cats would you have? All right, so there's 2 separate little experiments. This one, you can figure out the k from that. Once you know the k, then you can use these 2 and get your answer for how many cats you'd have in year 5. All right, so what's the equation? N of t equals n sub 0 e to the k t. Stick in the numbers, solve for k, then start the problem over again and put in that k, and you'll have your answer. I'll pause for a second and give that a try. Okay, check with the kid next to you and see if you got the same k value they did. Raise your hand if you had that K. Okay, any questions? Do you understand what I did, or do you think there's a mistake in there somewhere? Because there could be. All right. Then we start the problem again. I encourage you to just rewrite the formula. It's going to come down to this being really important, the formula. E to the kt. And then I stick in everything I know for this second experiment, this red one, where I'm trying to figure out how many there are now that I know k. I don't know the final, that's the point. I know the start number was 0. No, not 0. It was year 0, but the number of cats was 2. Times e to the kt. Well, k is something that I know from over here. And the time is 5. I would advise you to put the 5 first, just because it's easier. 5 is time, times k. And the k was 1/4 ln log base e of 4. And do you get this is solved? But it's got an e in it. That's just a number, 2.718. But it's got a log of 4. I don't know what that is. You could look it up in a chart or on a slide rule or in a calculator. So I'm done. That's the answer. You just don't like how it looks. I mean, it'd be great if the answer was just like 6, but it's complicated. But that's the way you can leave it on the test. All right. Congratulations. You just got through one of the hardest things that there is to learn for this upcoming test. Now, I'm going to take some more time on this, but do you get it's critical that you would practice one of these? Because if you're kind of just barely getting it right now, which is I feel like where most of you are, then getting a practice one tonight and looking at the answer key and getting one more chance to learn it will be so key. That'll be the difference between the A's and the B's. It'll be a moment like this, where the kid who's like really serious about it will take that extra time, and they'll probably then get this kind of problem right on the test, where the other kids will just be too much because just the class alone wasn't enough really to learn this well. You've got to go home and practice it. Paige, could you shut the door, and then what was your question?
Oh, I was gonna ask, do we have to know, like, does the formula have to be memorized with this?
Good question. We will give that formula on the test. You do not have to memorize that formula. It'll be given. All right. So if I was going to say let's do more, I'd rather have you do one more. And so if you want to, there's one in the notes that you could do right here, and then there's completed notes you could go look at. Notice you might be like, but that's a different formula. It's just a of t instead of n of t. You get the same exact formula. It just uses an a instead of an n. All right. Or you could just go to the actual homework, which is right here. And once again, they use the a of t formula. I respect how the notes asked us to use n of t, just to remind you that that's not like a law. It doesn't have to be a or n. It's this formula can have any letter for the big letter a or n, or it could be a q. All right. And this just kind of like walks you through it. What do you think they want you to find first? K. Now, they talk about decimal places. Don't do that. You don't have to do that on our test because the test doesn't allow calculators, so you could never get the decimal. All right. Another good example problem. This one starts by having you find K first. And this time it's half-lives. Is that different? Well, yeah. If you're cutting in half, you know that after that amount of time, you have half as much. So let's just talk about that for a second. Let's say that you have 2 grams of something at time 0. If they say the half-life is 8 days, do you get automatically, you can say at time 8, there's going to be half as much. Half of much as 2 is 1. You see how they really, by telling me it's half-life, they are telling me that it went from this to this? That makes sense? So they didn't outright just say, after 8 days there will be 1. But if they say the half-life is 8 days, that's what they're saying. Now it's just like the other problem we just did. All right, so it'll be critical for you to practice. I'm gonna stop talking and let you practice, and that's all I have for the video for today. Make sure you look at the key when you're done too.